Okay, so we should be live. Hello. Okay, give me a second here. Welcome. Hello. We're gonna try part 2 here. So yeah, I thought about this, took a break, thought about this problem a little bit more, and yeah, I think I have a solution now. Took a break, thought about this problem a little bit more. I think I have a solution now. Come back to this. So basically, what I had come to was a ON squared log n solution, and using interval trees, or what I thought was such a solution. And what I realized, let me read the problem again also. What I realized were a couple of things, and it is, yeah, bubble sort actually works reasonably well here. I'll explain. So I'm going to try that. This, I don't know what I was doing here. I don't remember, but it's wrong. I think we kind of just have to, like I said, just accept that a quadratic time solution is probably what we're going to be going with. And then this becomes a little bit easier. Let me explain. So that original solution was basically a kind of a bubble sort, but not really necessary to take this extra. It was not really entirely necessary to have this extra log n. In fact, excuse me, it's not really. You can there. I believe I've come up with a quadratic time solution that doesn't even require an interval tree. Let me read the problem again, for those of you who are wondering what this problem is. So, Q reconstruction by height. You are given an array of people, which are the attributes of some people in a queue, not necessarily in order. Each person has a height and a value k, which represents the ith person of height h sub I, with exactly k sub I other people in front who have a height greater than or equal to h sub I. So k basically means that there are that many people to the left. If we kind of write out our array from left to right, that many people to the left have a higher height. Have a height that's at least equal, or excuse me, yeah, height that's at least equal, is greater than or equal to at least their height. Reconstruct, return the queue that is represented by the input array people. The return queue should be formatted as an array q, where q of j is h of j, k of j is the attribute of the jth person in the queue. Q of 0 is the person at the front of the queue. So we take this example here. What we can do, I'm actually going to walk through the algorithm for you so you can see what I learned. There's a couple of things that I realized that can be taken advantage of, that you can use. So so here you have 704471506152, and you might be wondering to yourself, okay, well, I'll describe the algorithm that I'm going to run, and then I'll describe what the result is that we're looking for. So first thing you do is you take a look and see how many things, how many things to the left have a greater height for each value, and then compare it to k. So 0, there's nothing to the left that's higher, so 0 is fine. 4, we have too many things. We have k is too large here, or rather, we don't have enough things to the left that are of greater height. So actually, we could do the other way. We could do it's the way that I did it before. I did a plus. It doesn't really matter which direction you have. As it turns out, it could be plus or minus as long as you move in the correct direction. So here we don't have enough. Actually, here k is 3 larger than the number of elements to the left. Here we have one element to the left that's at least as large. Sorry, it should be at least as large, not larger. At least as large. 5, we have 1, 2 things to the left, but we have 0, so that means now we're k is 2 less than the number of larger heights to the left. Number of people that are at least as tall to the left. All right, 6, we have 1, 2, right, with 1, so that we actually have too many to the left, right? And 5, 2, we see 5, 1, 2, 3, 4. We see 4 of these, so we have too many to the left here, right? What I decided to do was first find these numbers, right, as you can see. And then what you're going to do is you're going to do each of these numbers are going to represent how many swaps you do in a certain direction, depending on the what do they call that? Depending on the, what's that called? It's the word, the parity, right? If it's positive or negative, the parity of this value. So what that means is 7, 0 is fine. 4, 4 we want to swap 3 times to the right with something that's larger. And you're actually going to skip anything that's smaller. So that's 1, 2, and the third swap would be here, right? Everything to the right is larger, so it's just everything. And you could prove a couple things about this, but we'll get into that in a moment. But basically, you're going to end up now with 7, 0. Actually, it's better to do it this way. It's better to type it. So you're going to put 4, 4, swap it 1, 2, 3 times where 6, 1 is, and then you're going to that's actually kind of it. It just looks just like that, right? And now we actually don't need to check again, because you could prove that if you do this correctly, and if there were smaller numbers in between, you would skip them. You wouldn't swap anything with those. You would just totally skip over those. If you did this correctly, you can actually prove that none of these values should change. None of the swap values should change. Only the value that you're interested should change. Everything else should keep the same. So 7, and you could verify it. We could verify it now by hand. So 7 is the right amount. 7, 1 is the right amount. 5 is still there's too many things to the left that are larger. 6 still has too many things to the left that are larger. 4 now is 4 is now in the right spot, right? We have 1, 2, 3, 4 of these are all at least as tall, and 5, 2 still has too many things to the left that are larger. And then now we can take 5, and now 5, because it's a negative, we want to swap in the other direction. So we do these 2 swaps in the other direction. Oops. So when we do this, same thing. Oops. Oh no, I made a mistake. I should probably put this in somewhere. 7, 1. What do we swap with? We put 4, 4 to the right of 6, 1, right? Let's do that quickly. And now we want to swap. The next swap we want to do is we want to put 5, 0 to the left of. Oh yeah, we already did that. Okay. And then we want to, right. I want to print that. So now, got this guy. Oops. Okay. So now we see there's nothing to the left of 5 that's at least the same size. Nothing to the left of 7 that's at least the same size. 7's still correct. 6, 1 now is still 2 things, right? And 4, 4 is still correct. And 5, 2 still has to be 2 swaps. And then we swap these ones, same deal, right? So 6, 1, 7, 1. Put that here. And again, we can verify 5 is fine, 7 is fine, 6 is the right spot. 7 is in the right spot, 4 is in the right spot, and 5, 2 is still in the wrong spot, right? Because there's still 1, 2, 3, 4, and k is 2. So 2 is 2 less than the total from the left, right? We want these numbers to be equal. So I probably should have done it the other way around, where this is a plus, and that means it's got to move to the left, because it's a little easier to describe. It's the number of things to the left minus k is 2, but here it's actually k minus the number of things to the left is minus 2. But it doesn't really matter. It's just one maps to the left, and the other one maps to the right, and you can can kind of do positive to the left or negative to the right, or you could do negative to the left and positive to the right, as long as you have them kind of differentiated. So that means we swap. Now here's what I was saying before. If something is smaller, we don't care about swapping it, and we skip it. And something that's larger, we do care about, and we want to swap. And so now we're going to do these swaps. So 5-2 to the left, and 4-4 is going to stay in the same position. And so let's do that. Show what that looks like. So 2 swaps to the left, but 4-4 stays in the same spot. Which this is not difficult to do this in an array. So now this should be our end result. Or rather, it's not expensive to do it. It's constant. Yeah, constant time. So same deal. So check. Oh, oops. Same deal. So check, 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 check. Right. Just 7 is the one there. 4, 1, 2, 3, 4, and then 7 is only the 7. 7, 1. Done. So that's the correct answer. So now the thing about this that's tricky is not tricky. Why does this work, right? Why do I not even need to? I verified at each step, but I don't even need to verify at each step, right? These numbers stay the same at each point. So the deal is none of these numbers will change for these values, and the reason is if you're swapping to the right a number that's smaller, and you're only going to swap it with things that are larger, then everything to the right is still going to to the right of that number is still going to have the same number of larger values to the left, if that makes sense, because all of those larger values are still to the left. The smaller value being pushed to the right of this larger value isn't going to change the number of things to the left of this larger value either. Also, all of the other values that were larger than this are still larger. All the values that were smaller, we're not swapping with this. So it won't affect the number of things to the left of this. And also those numbers themselves. Now, see, that's the thing I'm actually not sure about. I'm actually kind of stuck on that, a little bit uncertain. This might be a wrong algorithm, actually, because we're skipping over the ones that are smaller. The number of things to the left of that smaller value that are larger, I think it would change, actually. So that's a little weird. Because this is larger and it's being moved to the left, and you're swapping with another larger value, this smaller value that you're skipping over, the things to the left are the same. But the things, as you go to the right, though, you might have issues going to the right. I think you don't have issues going to the left, but you do have issues going to the right. Yeah. These aren't good examples. Yeah, maybe I'm wrong. Maybe it's the wrong algorithm. Maybe it's wrong. This one doesn't really have that test case that I'm looking for. Yeah, let's see. I'm looking for a test case where we jump over a smaller value. Oh, no, excuse me, I take it back. No, you're fine. No, it's fine. The reason why it doesn't matter if we jump over a smaller value is because we're only swapping with values that are larger. Yeah, no, I'm correct. I take it back. No, we're fine. I'm sorry. I did think that through already. Yeah. So this one. So if this was a smaller value and we skip it, because the thing we're swapping it with, all the things we're swapping with are all at least as large as this, right? Then those smaller values are still going to have the same number of things to the left that are larger. That was the reason, right? Just because it just so happens to work out that way, that even when you're swapping all these different things, you're swapping with things that are always swapping with things that are larger. So it actually doesn't affect these numbers. So what we can do is, the thing you do have to be careful about is that you want to quickly access at a particular index what this number is, how many swaps you still need to do. So when you start moving things around, those indices change. So you actually want to, you kind of want to do, the way I think I'm going to look to do it is I'm going to have an index, like an array for each index, like what the swap value is. So it's positive or negative number, right? If it's, we want these all to end up being 0. And when you swap, I'm also going to swap within that array as well. So that way, so that these numbers are kind of, these numbers relative to their indices are still preserved. And you kind of just go left to right, I think. Now, the thing is, like something like this 4, when you move it, you don't necessarily know if what you swapped into this position is now in the right spot too. It just so happens that this was a 0, but that could alternatively not be a 0. So you gotta kind of continuously iterate until you kind of get all the way to the end. But you would kind of potentially sit in the same spot, swapping things over and over again. But this should be a quadratic time algorithm. That's the key, which should be fast enough for this problem on 2,000 elements. So we're gonna try that. We're gonna try to code this up, see how we do. I'm gonna see a friend. Actually got invited to a barbecue, which I'm grateful for. So I'm gonna go to a barbecue in a short while, like 30 minutes or so. So yeah, that should be a good time. So yeah. So hopefully that made some sense. Hopefully that explanation made sense. I'm gonna try to code that up now. See how it goes. We're gonna get rid of all this. It was interesting to learn more about heaps in C++, but I have to say it was really confusing, the heap stuff I was looking at earlier. Yeah, so let's do this. Let's do standard vector int of deltas, we'll call them. And we're gonna say it's gonna be people.size, people, of 0. And we want determine delta values, call them delta values, which is the difference between a given person's k value and the number of people to the left currently that have a greater or equal height. And that we can do in quadratic time because our whole algorithm is going to be quadratic. So we just do a simple int I equals 0, I is less than people dot size plus I for int j is equal to I minus 1. We're going to go to the left from I. J is greater than or equal to 0 plus j. And we're going to say count 0 and say if people of j is greater than or equal to people of I, and the first value, right, the height, 0. I'm not using iterators at all because I don't know, I kind of just want to keep it really simple. And then we're going to say delta of I is equal to this count. You're going to increment the count in that case. Count minus people of I, and the k value is the second value, right? So these are the deltas that we described before, and then we want to perform the swapping. So we're going to do a while loop of int I equals 0, and we're going to say while delta of I is not equal to 0, right? we're going to do the following. We're going to perform swaps. Perform delta, absolute value of delta swaps, skipping smaller, skipping elements, smaller heights. And using the parity of delta of I to pick the swap direction. Hopefully that makes some sense. So now we say, okay, so it's not 0. So we say if delta of I is less than 0, we're going to do the following. And else if delta of I is greater than 0. Delta of I is less than 0. We were saying that the count minus people minus k, if it's less than 0, that means we have, I think it did the other way around. I think it did k minus, yeah, no, count minus k. So, no, k minus count. I think, yeah, k minus count. That's correct. Yeah, it kind of doesn't, like I said, it kind of doesn't matter as long as you map that correctly. But in these examples, I was using k minus the count, right? So if the k minus the count's positive, that means we're swapping to the right. If it's negative, so swap to the right, swap to the left. And again, we're skipping values that are smaller. Yeah. And we want to say, yeah, so int swap value is equal to and we're going to say, yeah, that's okay. Swap to the left. There might be a better way to do this, but we're just going to do it this way. So in either case, we're going to increment I. No, we don't necessarily increment I, by the way. We only increment I. And it's actually not. This is really a while. It's really, this is actually wrong. So if delta of I is equal to 0, then we're going to increment I. So this will keep us in the same spot. And we only really break when I is greater than or equal to delta dot size. Then we exit. And then we return. We should return. People, I guess. I want to modify this. We're gonna make we're gonna use a copy. We're gonna use people. We're gonna return people. We're gonna modify this. So what's gonna happen is that this will actually create a copy of what you input. That's there's this funny thing that I do from time to time. I've noticed where I'll create a const reference to the input, and then I'll create a copy here of the input. You don't need to do that. You could just leave this as it is, and it'll create a copy when it's input. Which is kind of funny, but yeah. So we can modify and return people just as a copy of the input. So what we want to do now is absolute value of delta swaps, skipping elements with smaller heights, and using the parity of delta to pick the swap direction. Yeah, a little confusing, I realize. So for actually, you can even just do swaps greater than 0, or yes, greater than 0, minus swaps. And we're going to say J could be int, yeah, swaps. We'll say J is I want to say, and let's say I minus 1, or we'll say I, yeah. We'll do it, yeah, we could do something like this. We'll do J equals, I don't know, okay, we'll do J equals I, right, okay. J equals I, so while J is greater than 0, or greater than or equal to 0, and, or J, yeah, J is greater than 0, and people of J, that height, 0, is less than people of I of that height. We're going to decrement J. All right, so this is moving to the left, swap to the left. Skip the smaller values. Standard swap people of I and J, and swap, this is kind of an interesting thing too, delta of I and J. So that's consistent. Swap those two things. And you do that over and over again for the correct number of swaps, appropriate number of swaps. And then from here, copy this code. And there's probably like better ways to do this, optimizations and things of that nature, but we're just gonna leave it as it is. And now swap to the right, we're gonna say, well, J is less than delta size, we're gonna increment J, size minus 1, and same deal, smaller. Now, actually, this should be, because if J is, yeah, you just need to put this here, if J is greater than or equal to 0. Because you may not perform any swap. Actually, no, there's a problem if, you'll get a runtime error. There should be a problem if, basically, if you make this equal sign and you end up going off the side, there's a problem because you won't be able to perform all the swaps you need to make. So this shouldn't matter. Same thing here. This should be, yeah. This is kind of a nuanced thing, but we could end up with runtime errors, possibly if my algorithm is wrong, but I don't think it's an incorrect algorithm. This is kind of like heavily relying on the input having a certain form in order for this to work, to making the assumptions I'm making. That's kind of interesting, but yeah, we might run into some runtime errors, possibly, hope not. If I coded the algorithm wrong, then we'll run into runtime errors, which is likely. That happens pretty consistently. I just coded wrong. Right idea, but the wrong sort of approach. So, or the wrong sort of encoding of the algorithm. So, or programming of the algorithm. So swaps, delta, J, swaps greater than 0, decrement swaps. So now we're going to the right, we're going to keep going while this is smaller, right? This will prevent the runtime errors if we do it this way, but it shouldn't matter if we put the equal signs in there. We shouldn't matter anyway, but we're going to. So we're going to skip the smaller ones, where that J is smaller, and we also probably should actually start J off at 9. not I. So he says swap to the left, it's -1, and swap to the right, it's +1. One slight detail. Okay, and now we're gonna do all this swapping. Swap deltas, swap the people, and yeah, okay, that should work. Let's see how it goes. Compiler error, nice. Deltas. Yeah, I did mean deltas, thank you. Also, this is one of the problems with duplicated code. You see, this is like basically duplicated code. Changes you make on one side don't necessarily translate to the other side. So you gotta change it multiple places, multiple times. It's always good when you. What is this? Oh, we don't need this. That's incorrect. Handy dandy compiler to fix all of my errors, help me catch my errors. What is this? Oh. Yeah, okay. Runtime error, nice. Really? No! Come on. That's too funny. Perfect. That's what I like to see. Immediately wrong. Nice. Nice. Alright, how are we doing? 30 minutes? Wow, it took a long time to explain that, huh? Let's just explain it and code it. What's the runtime error, though? What, how, did I make a mistake? I thought maybe I made a mistake here, too. Could be the other way around. 6. I don't know. That's fine. Okay. So let's just find out. Excuse me. Let's find out where this breaks. Oh, really? The very beginning. No kidding. Oh, duh. Going to the left, that's why. That's... Okay, wrong, though. Nice. What? Uh-huh. So interesting. What did I do? What did I do? Huh. Oh. Oh, I know I did wrong. Okay. So this is kind of interesting. I am missing something. Deltas of J at the end of this is equal to 0. That's the thing I'm missing. One of the things that I'm missing. I don't know what, yeah, again, making some assumptions about the problem here. Okay. Looks like we didn't do any swapping. No swapping. Really? No kidding. Huh. Or actually, I could just do this. Zero, 3, 0. Oh. Zero, 3, 0, -2, -1, -2. You know what? Let's do this. Oh. Duh. Right. TLEs. Okay. Let's also do one test case at a time. Okay, so 0, 3, yeah, we can get rid of the first one. Don't need that anymore. It's a little confusing. I was kind of wondering what was going on with this program. So 0, 3, and should be, so 1, 2, 3, right? So it was 1, 2, 3, and somehow, no, that's wrong. This 3 should be the one that goes to 0. Also, why did all these zeros come from? This one swap is fine, but this 0 shouldn't be there. And then this next swap with -2, this negative, yeah, that's wrong. Okay, something went wrong. Something went very wrong. Okay. Swap to the right. Swap, 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 and then what? This should be okay. Oh no. Well, the first iteration we skipped the 0, so we really just yeah, we just go right to +1 and print, and then this one. So that's kind of interesting. We swap 0 with 3, but we should also swap 3 with -2 and -1. And for some reason there's 0 over here. So I don't know what happened. Oh, I think I understand now. Oh, I think I know what happened. Okay. You're swapping the previous values, that's why. When you swap, you want to update. Yeah, we'll just call it alpha. Swapping to the left. Okay, I see the problem. Yeah, okay. And we're going to say deltas of I. That's fine. Yeah, this only gets set once. This doesn't matter. This could just be, we can change this to alpha I, whatever you want. But this matters because it's alpha. It's changing, and it's going to be swap alpha and J. And the reason why that matters is because you're going to update alpha to j. Yeah. And then, oh, that's so confusing. And, right, alpha becomes j, and j is increments by 1. Yeah, very confusing. Right. And in fact, actually, if you're going the other way, right, something like this. Oh boy. Oh, that is so confusing. That is so confusing. Yeah. Gulp. Alpha's the thing we want to change. This is, I would not be able to solve this in a coding interview. Forget it. It's a big nope. Nope. Let's keep this consistent too, just for the sake of. I get this feeling like this is going to be wrong anyway. This algorithm, like it's not going to be fast enough. Runtime error. No. Come on, man. Really? Please no. Say it ain't so. Say it ain't so. It's also supposed to be alpha. Oh, it's correct. Hey, of course it is. Of course. Of course. I don't know. Part of the problem that I have with this particular problem is generating the test cases. It seems like it's kind of a pain in the neck to generate test cases. I'm fairly confident that this is right if it works. We're just gonna go for it. I don't know. I'm like, part of me feels like maybe I should be a little more cautious about going for it, but another part of me is like kind of had enough. But I'm okay at this point. Okay, there's like a lot of, I'd have to go through like a lot of test cases, and I'd have to like think about this more, and it's like I'm kind of done with this problem. I've spent I don't know how many hours now. It's like approaching 6 hours. It's like, it's okay. I really don't need to keep going. So apparently we're wrong, and I'm sad. I'm sad. Why would this be incorrect here? We're so close too. 5362. Really? How did that happen? Really? I thought it was right. I thought I was so sure it was right. Oops. Okay. Wow. I don't really have the, if it's wrong, I think I don't, like, I think that's all I got for today. Like, it's pretty much, I must have programmed something wrong. I don't think so. I think if I programmed something wrong, this program just wouldn't work. Yeah, I don't know. I think it's just the wrong algorithm then, in which case I think we just lose game. GG, well played. Yeah, I don't know. I think we'll just have to come back to it then. I don't really want to think about this problem more though. This is like kind of too much for me. It's too much, it's a lot of work for Leetcode medium, and even like a Leetcode hard. Like, I don't want to spend like hours and hours and hours trying to solve these problems. Because there's usually, when you're spending that much time on the problem, there's usually some like kind of subtle thing that you're missing that's like really, really hard to think of, and it would just take forever to think about it. And like, why do you really want to waste your life thinking about that? It's kind of how it feels with these things. It's like, why would you bother? It becomes this question of like, what's the point? Some people figured it out, but you don't have to spend all your time figuring it out. And I've been kind of thinking about that about my life in general lately. It's like I feel like I've made a lot of really wrong decisions because it's like I feel like I've just wasted so much time doing things that don't matter. And I kind of wonder sometimes, like, what I don't know. I don't want to think about it too much because it kind of makes me sad. But yeah, it's, I don't know. It's hard. Just say it's hard. Also, what did I just do? Did I break paint? I think I broke paint. Is that a bug in paint? If you use the undo feature enough, you just break it. Nice. It starts having unexpected behavior. Maybe I should restart paint. Just rest in peace, paint. Nobody's ever bothered to use that many undo features. Use the undo feature that many times in paint. Okay. Anyway. Oh, you know what I did? I think I know what I did. I don't think I broke it. I think I hit the button too many times and it erased this part, and then I wrote something without putting this back. I think that's what I did. I don't think I broke it. It just, yeah. I probably would have noticed that more often if it was broken. All right, yeah, that's probably my last shot. If I can, actually, I probably won't even. I'll probably just end it here because I want to go see my friend. Go to the barbecue. Yeah, pretty soon. Okay, so 9 is fine. 7 is not fine. 7 has too many. 1 is not enough. 3 has 1, 2 is not enough. Oh no, 3 has too many. Excuse me, 1, 2, yeah, too many. 3 has too many. 2 has 1, 2, 3. I think it needs 4. 5 has 1, 2, which means we need 1 more. 6 has, yeah, like I didn't do enough testing on my algorithm, like definitely not, but like I don't know, it's just too many tests to do. Like I have to think up all these different test cases and take all that time, which I just kind of don't want to do. That's sort of another issue that I have with like algorithms. Is like that's kind of generally what you do is you just kind of run data on like through different test cases until you have like some idea of an algorithm that might work. That tends to be how you solve problems, how I solve problems, and how I solve problems. It's like you just keep going, just manually do a bunch of test cases, and eventually you'll notice things that are true about the problem, and then you can take advantage of those things that are true and optimize your approach. But like it's a lot of work to do that, you know. It's just like a lot. 1, 2, 3, 4, 5. So too many to the left. 6, 1, 2, 3. So I have too many to the left, and then 5, 1, 2, 3, 4, 5. So I have too many to the left. Okay. So we would. That's gonna take me some time, huh? We would move 9. We would move 7 once. We would skip this guy, and this guy, and this guy, and this guy. Oh no, I'm sorry. We go to the left. Swap here. 7 and 9. We should get. Now check. 1, 9. Swap that a bunch to the right. So that's going to be 1, 9 with something larger, then these two with something larger, right? 1, 9 with 2, 7, then 1, 9 with 5, 7, 1, 2, 3, 4, 5, 6, 7. Let's move that all the way to the right. So 1, 9, and 6, 2. Okay, so check, check, and now 6, 2 is -1, but 1, 9 should be a check now, right? And it should be 1, 2, 3, 4, 5, 6, 7, 8. Oh no. 1, 2, 3, 4, 5, 6, 7. Whoops. Not 6, 2. Wrong. Should be actually, that whole thing's wrong. Five, 2. Okay. Okay. 7, 0, 9, 0, 1, 9 is in the right spot, and 5, 2 we said is -3. So let's do that. So now 3, 0, 2, 7, 5, 3, 6, 0, 3, 4, 6, 2. So 5, 2 would then move, no. Oh, really? Oh, that's wrong. No, 5, 2 is not. No, no, no. 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 You moved everything that way. Okay. I did this wrong. I definitely did this wrong. Okay. Yeah. Huh. Whoops. No. 1, 9 gets moved all the way over here, but everything else just gets shifted down. Yeah. That's okay. Confusing, but yeah. You just shift everything down. That's what's supposed to happen. Right. No, it is correct. It's all right. I don't know. Okay. Anyway. Yeah. So there you go. So now 3, 0 is -1. 1, 9 is fine. All of these things should be the same. All of these should be the same. They all just got shifted over. All the things that got shifted over are larger than 1. And they all got moved in the same direction. I guess maybe you could shift something over that's larger than 1 but less than something. No, the only things that you skip are things that are smaller than 1. Yeah, no, so it should be fine. It should stay the same. So now we shift 3 with 9. It should be right. I think I just coded it wrong. I mean, it must have. Pretty sure the logic works. So 7's fine, 3 is fine, 9 is fine. Oh no, 3 is not fine. Wait, how does 3 have a 1? 3 should be 2. That's my mistake. Yeah, shift everything down. It's basically a kind of modified bubble sort. This algorithm, but man, is it taking me a while to get it right. 2, 7 we said is 4, which I think is still 4, right? 1, 2, 3 things to the left, and that are larger. So we'd have to move that to the right a few times. 1, 2, 3, 4, right? I get it going. 1, 2, 3, 4. So it's between 5, 2, and 1, 9. No, it's not between 5, 2, and 1, 9. It's between, it's in front of 5, 2, and 1, 9. Yeah, it's in front of 5, 2, and 1, 9. Perfect. Okay. What else we got here? So 3 is fine, 7 is fine, 9 is fine, and 5, 3 we said is +1. That's still +1, right? 5, 1, 2 to the left, yeah. And this thing that we just moved was 2, 7. 2, 7 should be fine now, right? 2, 7 should be 1, 2, 3, 4, 5, 6, 7 things to the left. Yeah, okay. And then, right. And 1, 9 should still be, right, 1, 9 still fine. 5, 3 we're going to move to the left because it's one, there's too many things that are, or excuse me, I'm sorry, 5, 3 we want 1, 2, 3, no, 2 things we want to move to the right, right. 5, 3 we want to move to the right. 1. This seems okay. I don't know what I did. I did something dumb here. I think I just coded it wrong. So 6, 0 should be swap with 5, 3. I think I just coded the wrong algorithm. Something foolish to code the wrong. I don't know. Maybe the algorithm's wrong. I don't know. Check, check, check. This is not a check. That's a check. 1, 2, 3, 4. 6 has too many things to the left though, right? We said 6, 0 has -2. So 1, 2 things. So that's going to be moved to the left. And then 5, 3 is fine. And then 2, 7 is good. And 1, 9 is good. And here we would move 6, 0 to the left once, twice. So now we have 6, 0 is here. Check, 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 check. 5, 3, check. Wait, 1, 2, 3. 3, 4 is -1. Should be, right? Things left of 3. 1, 2, 3, 4, 5. Oh, yeah. There's too many things left of 3, 4 that are larger, right? Yeah, should be. You gotta move 3, 4 to the left, and then we said 2, 7 is fine. 1, 9 is fine. Yeah, that's good. How does it? Okay. Well, all right. So now we move 3, 4 with 5, 3. All right. Swap those two. Oh man. Check, 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 check. 3, 4. 1, 2, 3, 4. 5, 3. 1, 2, 3, 4. No, excuse me. 1, 2, 3. Check. 2, 7. Check. 1, 9. Check. All right. 6, 2 and 5, 2. So 6, 2 is -1. And 5, 2 is -3. Right. 1, 2, 3, 4, 5 things that are to the left of 5, and then 6, 2 is 1, 2, 3 things, right? -1. Yeah. Okay. So now 6, 2 swaps with, it skips 5 and 3 and swaps with 9. Aha. Interesting. Okay. I think that makes sense. I think it's fine. So that's sort of the first time we do any real skipping. So 6, 2 is going to swap with 9, 0. 6, 2 swaps with 9, 0. And what's interesting is that this swap is like a legit swap. Like it's swapped, right? So yeah, you have 3, 0, 6, 0, 7, 0, 6, 2, 3, 4, 5, 3, 9, 0. And then, yeah, that gets legitimately swapped. 2, 7, 5, 2, 1, 9. Yeah, okay. And we're gonna verify. So it looks like I actually coded the algorithm wrong, which is good, because it looks like the algorithm is right and I coded it wrong, which is a positive thing because I was pretty sure I was correct with the algorithm. Like I was pretty sure I had it right. Just, I mean, coding it's kind of awkward because it is a weird kind of an algorithm. It's really unusual. 2 things to the left are larger than 6, right? 1, 2, 3, 4 things to the left are larger than 4. 5, 3, 1, 2, 3 things to the left of 5 are larger than 5. Nothing that is to the left of 9 is larger than 9, less than greater than equal to 9. 2, 7 is the same, right? 1, 2, 3, 4, 5, 6, 7 things are the same. And then 5, 2 I think is still a -3. And 1, 9, everything to the left is larger than 9. Okay, now we gotta swap 5, 2 to the left 3 times. So skip 2, swap with 9, swap with 5, greater than or equal to. Oh, is that what I did wrong? Yeah, greater than or equal to it should be. Oh no! Oh, that's what I did wrong. It's just an equal sign. Oh, why do I do these things, man? You're kidding. Still wrong though. No, okay. Interesting. No, I'm sorry. Actually, I was right. The ones we skip are less than. No. Wait. Yeah, we skip. Yeah, no. I'm sorry. This is right the first time. Take that back. But still, what happened? So swap 5, 2 with 9, 0, 1, 2, 3. So oh no. 1 with 9, 0, 1 with 5, 3, skip 3, 4, and swap with 6, 2. Okay, is that right? Is that what we're doing? So okay, we got a couple of hops here. Yeah, this is where it gets interesting, right? This is the kind of thing that I would have liked to would have tested on my own if it didn't take so much time. Like how much time it takes to do this by hand. It's like I don't know how many minutes I spent. Okay, so skip 2, swap with 9, swap with 5, skip 3. Only things that are greater than or equal to, right? That we swap with, and then 5, 6, 2. So now we're gonna have the following. It's gonna look like something like this. Okay. Basically shift 5, 2, swap 5, 2 with 9, 0. Swap 5, 3 with 5, 2. I'm wondering if I should skip things that are equal. I don't know. Yes, 5, 2 with 5, 3. And then, so 5, 2 with 9, 0. 5, 2 with 5, 3. And then 5, 2 with 6, 2. Okay, now we get this guy, I believe. So yeah, this could be wrong. Maybe, okay. So 5, 2 is now where 6, 2 was, and 6, 2 is where 5, 3 was, and 5, 3 was 9, 9, 0 was, and 9, 0 is where 5, 2 was. Okay. So this is still fine. This is fine. This is fine. 5, 1, 2, fine. 3, 4 is 1, 2, 3, 4, fine. 6, 2, 1, 2, fine. 5, 3, 1, 2, 3, 4. Wrong. What happened? Uh-oh. 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 That's interesting. That's interesting. How did that happen? 2, 7 is fine, 9, 0 is fine, 1, 9 is fine. But 5, 3 somehow. So we weren't supposed to touch 5, 3, I think. Which is a little weird. Why did that happen? So because we moved 5, 2 to the left of 5, 3, and that's a big no-no. That's a big no-no. Yeah, so things that are equal you don't want to swap with either. You want to skip the ones that are equal. So we do want to skip the ones that are equal. Okay. But we still get the wrong answer. So I was right about the equal thing, but I'm still wrong. Really? Yeah, because the ones that are equal, this actually contributes. The thing that you're swapping would contribute to that one. So you don't want to. You want to skip that. Actually, I don't think it matters if you skip it or not. No, you should skip it. No, you should. No, I'm right. Yeah, you only want to swap with things that are larger. So you swap with 9, you would skip 5, you would swap 6, 2, and 7. So 9 would go to the right, and then something would go to the right of 5, 3 as well. But then the whole algorithm changes after that, right? So then there's some other break somewhere in here. So what do we end up with ultimately if we incorporate that part? Yeah, no, the whole thing is wrong. Did we get the same output that I was expecting here? Slightly different output. Well, now this 5, 2 is wrong. This is almost the same thing, except this 5-3 and 6-2 are swapped. Yeah, if you do that last step, maybe I'm just wrong. Oh man, no kidding. Put that a little lower down. Oh boy, I gotta go. I'm gonna be late. Dude, what is going on? Oh boy. So these are all correct except, just checking again, except this 5-2. 1, 2, 3, 4, 5 minus 3. 3 of these things to the left. So what's interesting about this is that actually you could just swap this 5-2 and this 5-3 and you'd be done. I believe. Yeah. That's kind of ironic. Not sure exactly. I mean, I think that's actually what's supposed to happen. I don't know why. That's interesting. Wasn't expecting this, but yeah, actually, if you just swap those two, this works, which is kind of weird. It's a little weird, but anyway, so what happens now is we skip 2, swap with 9, skip 5, skip 3, swap with 6. It's got to be 1, 2, 3 swaps, and then finally swap with 7. No, see, that's the problem. We do need to swap with 3 with this guy. We do need to swap that because that's one of the things that contributes to this guy. But the problem with doing that is that now the things to the left that contribute to this are increased. Oh, so when you swap, so you run into problems when you're dealing with things that are equal to each other. Oh, no kidding. That breaks this algorithm, doesn't it? I think it does. Yeah, you can't just, yeah, you run into a problem. What I would say is, actually, you just swap those two at that point and you're done. Right? If the element, that's such a problem, isn't it? I want to say if you have an element that you're gonna swap with that's the same height, and then undo all of your swappings and just swap those two. I think that's what you got to do. I don't know. That seems weird though. Yeah, because the problem with, well, I think it's okay. I think you just stop there. I think you could just stop there, and the reason is, you did, until that point, you did swap things that are larger. And even though when you swap these two, so yeah, because the problem with swapping with something that's equal, right, is it will increase this number. It'll change this number. So you never want to swap with something that's equal. But you don't want to go to the left of it either, if it's equal, or to the right. Because if you swap this 5-3 with this 5-2, it actually invalidates the 5-3. Oh no. Sad. My algorithm is wrong. I feel like I have to. I feel like I need to implement the interval tree in order to get this to work properly. No. Yeah. I didn't think about that. That if they're equal to each other, then what happens? Because if you do this swap, and then, or even if you do this swap, it's still wrong, right? Because this 5-2 will have 1, 2, 3. Like they'll both be wrong, and then this 5-3 will have 1, 2, 3, 4, 5. So it'll be wrong, and this will be wrong. What is the expected result, by the way? And can I get from this expected result to the one from can I go from one to the other here? Okay. Yeah, can I easily go from one to the other? 1, 2, 3. So what's interesting is it looks like it's actually kind of similar, huh? It looks like the 9 did get swapped over here. 6-2 got swapped with the 9. 5-3 was skipped, and that was it. I guess you just skip over the 5-3, but count that as but still count it. Oh, that's interesting. Okay. So you don't swap 5-3. You don't even touch it. You just don't touch the one that's equal. Oh, that's really interesting. So you skip a swap. Okay, that makes sense. I think that makes sense. Yeah. If they're the same height, you don't want to swap them around, because if moving this 5-3 then throws it off. Because actually the thing that you're moving to the left of it is, so you want to only swap with things that are larger than its height. And the things that are equal, you still want to increment j, but you don't want to swap them. So I think that's kind of interesting. Okay, well, a little bit of cheating, I guess. But that's such a subtle thing. I mean, I think I would have picked that up if I had tested more cases. So you just don't do the swap if they're equal. So we say if alpha of, or people of alpha equal of 0 equals people of alpha of, or j, I don't know, people of j of 0. If they're not equal, then we'll do the swap. Otherwise, you just skip right over it. We'll say if they're equal, if they're not equal. I think it's got to be the alpha's got to be greater than for the swap to happen, right? No, j has got to be greater than, right? we're only swapping things that are larger than this guy. So you skip one of the swaps. I think you do that in both cases. Same logic, same code in both cases. I think that'll handle this case. Still wrong. Nice. It's closer. We did these swaps over here. I think the only two things that are equal are the 5 and the 5 and the 5, right? Everything else is different. Oh, there's a 6-0 and the 6-2 also. Interesting. So 1-9. Do we ever end up swapping like multiple 6s? I don't think so. No. Not sure if that should matter. You're always swapping with something that's larger. Yeah, so this one thing at the end here. 6-2, 5-3, 5-2. How come I really gotta get going? Oh, I'm late. I'm very late. I'll probably just pick this up later. I don't know. How is this output different from the output we had before? This is different from what we're looking at up here because of what happened. It looks like we got really close. 6-2, 5-3. So we did end up swapping the 5-3 with this 6-2, which is not what we want, right? And so this 5-2 we swap with the 9. Then 5-2 should swap with should swap with 6-2. No. Wait, what? Oh, well, that's okay. My brain. 5-2 swaps with the 9. That I think makes sense. Somehow we got 6-2 is to the right of the 5. We got 5-3 and 5-2. 6-2 is here. How did 6-2 get to the right of both of these? That doesn't make sense. 6-2 would just end up. I swapped 6-2 with. Wait, what? 5-3 shouldn't have been touched at all, right? Should have just swapped 6-2 with 5-2. Yeah, so I think. Oh, is that right? Is this part supposed to be included in the swap? Skips, which part of it gets skipped? I think we just increment J again. I think this is supposed to be there. I don't know, I gotta like really think about this. Oh, there we go. Okay, right. Alright. Just try more test cases. Nice. Okay, I think the algorithm is close, but still wrong. Great. Alright. Nice. Something's wrong, I don't know. Yeah, I would just need to go through more test cases. I think for a problem like this, I would just need to do like more analysis, just more test cases, more data, more information about the problem. It's kind of what it comes down to when you're like researching a problem. Like you just need more and more information, and then eventually you'll start to see patterns and like things that you can take advantage of and things that you can optimize and all of that. Things that, yeah, work that doesn't need to be done and all of that, all of those things of that nature. It's kind of what it comes down to. So problems where it's awkward to set up test cases and test your algorithm on them, I tend to do poorly on those questions. This is a kind of question that's similar to that. I still stand by a bubble sort with an interval tree would work, but I thought the algorithm I wrote here would also work. I was wrong. I was wrong. It's not correct. The reason it's not correct is it seems to be when you're dealing with values that have equal height, it gets kind of funky. And there's probably some cases that I'm edge case type things that I missed. I'll have to go through more to see like where it's wrong. It's pretty close though. I don't know. Maybe it is just wrong. I don't know. I'll have to keep working on it. Thank you all for watching. I'll talk to you soon. Have a good rest of your day. I'm going to go see some friends. So yeah, take care.